Hello everyone, welcome to a new video. In this video we are going to discuss binary logic. This topic contains number system and we are going to see what is binary logic here. So if you're new here, I would like you to subscribe to our channel, give it a like if you enjoy this content, and share this with your friends. So this is basically for NIOS senior secondary course. Otherwise also computer student science can use this content. So let's begin. So the first thing is, what is binary logic? So the word binary stands for zeros and ones. That is the language used by your computer. Computer can understand zeros and ones other than the normal language that a human can understand. So the logic, including this binary zeros and ones, or the system of reasoning or operations based on these binary values, which are represented by zeros and ones, we call it as binary logic. It forms the foundation of digital circuits and computer system. Okay. Then in binary logic, operations like AND, OR, NOT, XOR, and others are used to manipulate the values which are given by binary values. Okay. Also, binary logic is used in computer processors, memory devices, and digital signal processing, where information is passed in the form of binary. Binary stands for 2 digits, zeros and ones. When it comes to the number system, it is divided into 4. You can see here, where binary stands for zeros and ones. A combination of both can come together. When it comes to decimal numbers, it is always 0 to 9 and the base is 10. In case of binary, the base is 2. Now comes octal. Octal means the base is 8 and it is expressed from 0 to 7. Next one is hexadecimal. Hexadecimal values are represented from 0 to 9 and from A to F. Okay, we will see in detail what are they and what are the conversions possible for them from one number system to another. So any decimal number which needs to be converted to binary, how it has to be done, we have to see. So when it comes to binary, you have to identify the numbers as zeros and ones. Any combination of number, like binary numbers, are represented as a combination of zeros and ones. So any number like 1, 0, 1, 1 can be a binary number. So decimal, you have to convert it to decimal, which is usually a normal number given to you, like 43. It is a decimal number where it is represented like this, and binary number is represented in this manner. So you have to do conversion from decimal to binary and binary to decimal. So you have to follow some steps to do that. So when a number is given to you, consider it is a 43 and you are trying to convert it to binary. Okay, so you identify the difference between both of them. This is binary number since it is in the format of zeros and ones. This is a decimal number. So we are trying to convert decimal to binary. Now to do that, what we have to do is we have to continuously divide it by 2, since the base is 2 for binary, and store those remainders on one side. Let's see how to do that. So if it is 2, it will be 21. You see here, you will find that when 43 is divided by 2, or when we find the prime factorization of that number. So why we are taking this 2 is reason we are going to convert it to binary form. So when finding the prime factorization, we arrive at a remainder here. So to this is the prime factorization of 43 that you usually do in mathematics. 2 into 21 will give you 42, not 43. So 1 is remainder. 2 into 10 gives you 20. 1 is remainder. One extra number, that is 21, is here. So that 1 comes as a remainder here. So this side you can see all the remainder. And 2 into 5 will give you 10 without any remainder. Okay, nothing is remaining here. 2 into 2 will give you 4, not 5. So 1 extra remainder is here. 2 into 1 is 2. That means it's completely divisible, so 0 remainder. So you have to write it in this format. And then how you find out the binary value for that is start from this side. 1 and 0 numbers are only left out. You can see here 1, 0, 1, 0, 1, 1. Write it in that format. Okay, 1, 0, 1, 0, 1, 1. So this is what the number you get as binary value for 43. So this is the solution of the first operation, that is decimal to binary conversion. We are going to convert binary to decimal now. So we are taking the same number as example that we have just now got here as binary form. So write it down in the order. After that, starting from the rightmost side, you are going to multiply each number with a power increased every time with the 2. Why 2? It is because of binary. We are going to convert that decimal binary, since it is a binary number, we are going to do 2 raised to 0. Okay. Now it is 2 raised to 0, then 2 raised to 1, then comes 2 raised to 2, 3, 2 raised to 4, 5, and goes on increasing in this manner. And each time you have to go to the left side so that it gets multiplied. So here we can write it as 1 into 2 raised to 0, that is 1, plus 1 into 2 raised to 1, again this is 0, so you are automatically going to get it as a 0, so no need to write it completely. Again it is 1, so 1 into 2 raised to 3 plus, again it's a 0, you can write directly 0 because 0 into 0 multiplied by another number is 0. Again 1 into 2 raised to 5. Okay, so when you elaborate it, what you are going to get, let's see. 1 into 1 plus 1 into 2 plus 0 plus 1 into 8 plus 0 plus 32 into 1, that is, this is the solution. And then 1 plus, again simplify it, 1 plus 2 plus 8 plus 32. Okay, that gives you 42, 42, 43. So the solution is 43. So we have done from decimal to binary conversion and binary to decimal conversion. Hope this is clear to you. To do the decimal to binary conversion, you already will be having a decimal number, so you have to divide it by 2. In the other case, that is binary number is given to you, you have to multiply it with 2's exponent, increasing from 0 to till how many digits you have. Okay, follow these steps for doing that. We are going to see how to convert from decimal to octal and octal to decimal conversion. So here let's take a number which is in the decimal format. So it is 473, that is taken. So now we have to convert it to octal form. So since it is octal, the base is 8. So in this case you have to divide it with 8 like we did for our binary number. Similarly, it is octal, so 8, that's why 8. So when you go for dividing or prime factorization, it is 59 that you get with 1 remainder. So this remainder is very important. Again do with 8 and you get to see 7 8s are 56. You get to see the 3 remainder here. Okay, so again we can't do with 8 since 7 is smaller than 8. So let it be like this and start writing from this corner 7, 3 and 1. You can see here 7, 3 and 1. Only the remainders starting from this side. So it is 7, 3, 1 in your octal format. So you can write it as 8. Okay, before it was in decimal format 473, and now you converted it to octal form. Now how to bring back that octal form to your decimal form? Let's check here. So I'm not changing the number. Let's see how we are doing that. 731 is in octal form. Okay, we are converting it to decimal form. That is why each digit should get multiplied by 8's exponent starting with 0. So it is 8 raised to 0, 8 raised to 1, 8 raised to 2. Similarly to your binary conversion, but here the number is 8. So we go for much simpler way. Now 1 into 8 raised to 0 plus 3 into 8 raised to 1 plus 7 into 8 raised to 2. Here you get 8 raised to 0, or any number raised to 0 is always 1. So it is 1. 1 into 1 is 1 plus 8 3s are 24 plus 64 into 7, that is 448. After simplification, you will arrive at an answer that is 473. Okay. So if you check, it is in the decimal form now, and 473 is the number that we started with. That is, our decimal number was 473, converted to octal, that is 731 in the octal form, and then again we converted it back to decimal form, that is 473. So hope you understood how we are doing this calculation. First we are dividing with 8 to bring from decimal to octal, and from octal to decimal we are multiplying by 8. Okay, hope this is clear to you. Let's move on to the next topic, that is decimal to hexadecimal conversion. Similarly, back from hexadecimal to decimal conversion. Let's see the first one. In this case, we are selecting decimal number as 423. This is in the decimal format. Okay, we are going to convert it to hexadecimal. Since it is hexadecimal, our base is 16, and we are going to select 16 here and try to divide it. So when you divide, you get it 26 with 7 remainder. Again go for 16 division, and here you will have 16 ones are 16, and you are left out with 10. Value is 10 here. But as you know, in hexadecimal we are not using a value more than 9 as 10, 11 like that. We are going to change that as A to F. Okay, for 10 it is A, 11 it is B, 12, 13, 14, 15, 16. Okay, so for all this, these are the values that we use. Okay, till 16 these are the values. 0 to 9 is used as such. So in this case, when you convert it to hexadecimal, further conversion is not possible here, since 1 is the number that you got here. So 1, 10, 7, you can't write it this way. Instead of 10, you have to write it as 1A7. Okay, this is in your hexadecimal format. You can write it as 16 here if you want to. This number is in your hexadecimal form. Now when you want to convert it back to your decimal format, let's take the same number. So 1A7 in the hexadecimal form need to be converted to decimal form. So for that, what you have to do is 16 raised to 0, 16 raised to 1, and 16 raised to 2. Now multiply the same way how you did for octal and binary. 7 into 16 raised to 0 plus A into 16 raised to 1 plus 1 into 16 square. Okay, so after conversion you will be arriving at the answer 7 plus A into 16 plus, after that you have 16 square, that is 256. Since it is A, we already know that A means 10 here, so write it as 10 into 16 plus 256, and here it is 7 plus 160 plus 256. So at the end you will get the solution as 423. So this is conversion to your decimal back from hexadecimal value. How do you identify it is a hexadecimal value? Since the A has been used here instead of 10. Okay, so it's hexadecimal. Now the value that you will receive at the end is decimal value. So in this lesson, we have seen what is a binary logic, what are the different number systems that are being used, and we have seen what are their bases, how to represent them, and then we have seen conversions from decimal to binary and back to decimal from binary. Okay, so 2 conversions we have seen here. Next 2 conversions are decimal to octal, octal to decimal, 4 conversions. Now next one is decimal to hexadecimal and hexadecimal to decimal. So 6 conversions we have seen in this video. If you have found this video useful, don't forget to give it a like. Do share your feedback in the comment section. Subscribe to the channel and share this with your friends who are also preparing for the same subject. This content is based on NIOS Senior Secondary. Computer science students of other streams can also use this. Thank you for watching.